One of the biggest challenges to milling is determining the proper strategy for the workpiece. And in this case, we've got a project, a ring project, that has a little open gallery work down here, and then along the outer face of the ring has some seats for the stones and some prongs. So let's go ahead and enter into the Revo C Builder and take a look. I always begin by placing my model in the model window. And you can see it picked up that there's a ring, that it's a ring model, because your finger rail is present in the model. Sometimes the deciding factor on what strategy you're going to choose is going to be time. Sometimes you have more than one option, and time is really the deciding factor. And in this case, there's two approaches that would mill this pretty well. One approach would be to mill in from both sides and then have a hub and place it on the rotary. So this option with the hub option. And the other option would be to use the base clamp. And the base clamp, we'd have to come in with some custom angles for that. Now the auto flip, or the dual fixture plus rotary option, is probably going to be a little quicker than the base clamp fixture. The base clamp tends to take a little more time. So in this example, I'm going to show you how to insert some custom angles on the rotary axis. So we're going to be choosing the first option for the support type, and then we're going to choose the hub for the center type. And you can see when I clicked the support option, the supports were added to my model. So that is an automated process. And it left a big gap here at the center. When we changed from the dual fixture to the 3-prong mandrel, we're going to need to make sure it's perfectly aligned, and there's going to be a slide rule that's automated in the software and will be placed in between those two supports. So I'm going to go ahead and click next here. And on this page, it always is going to hand you back the appropriate size wax for the specified job. In this case, it's telling us that a 5mm piece of wax will be sufficient to cut out this ring. In the event that I do not have a 5mm piece of wax, I'd want to change this to whatever wax size is the actual wax that I'll be using for my project. And in my case, I have a 5mm piece of wax, so I'm going to leave it at its default option. I'll go ahead and click next here to proceed. And on this page, we determined the approach angle. We have 3 automated options to choose from. We can approach the project flat on 2 sides, from 3 sides, adding in the top, or from 5 sides, adding in some custom angles. Okay? And when you first glance at the model, you see this big open area up here at the top, and you think, well, definitely number the 3 sides or the 5 sides. But in all reality, here's what's going to happen. Okay, I just extracted the tool path out of here so we could take a look. And what's going to happen is when the cutter approaches flat on 2 sides, if you look at the tool path here, when the cutter comes down from one side, it has to actually move away slightly from the geometry so it doesn't impede. If it were to make a flat edge here, well, it can't because it's a tapered cutter. Okay, so it would impede that geometry and cut into your ring. So what happens is the Revo sees that there's geometry there, and it steps away from the geometry. And the evidence of that is this 5-degree angle left from where the cutter could not touch it from both sides. So you can see, even though the bottom of the ring is flat, you're going to be left with this chunk of wax all the way around your ring. Well, let's go ahead and get rid of this stuff. Okay. Well, up here in this section here, as we come around on the rotary, it's going to clean off all of the excess wax. Okay, but when we come in from the top, it's going to only be able to clean where it can reach. So this entire section here is not going to be milled, and this entire section here is not going to be milled either. You can see in the image below that it'll leave an area on either side of the bridge that is not milled out completely, and that's going to have to be cleaned up by hand. So I'm going to show you how to deal with that within the software so that you don't have to clean it up by hand. So in my option, what I'm going to do, let's get those supports back. I'm going to choose the second option, and I'm going to leave that 5-degree angle everywhere. I'm going to avoid cutting out the center section altogether. Click Next, and on this page we're going to choose the appropriate hub size. And in this case, we know that we're going to be using a 5mm piece of wax, so we need to make certain that our hub is less than the size of the wax that we're using, so that it actually mills out the hub. So we want the hub to be slightly smaller than the bottom of the shank, which is the bottom of the shank looks to be about 3.5mm or 3mm, and we know the hub is, or the wax is 5mm. So let's go ahead and choose a center core size of 4. We also have the option to choose the number of inner supports, and we can choose from 3, 6, or none. And if you choose none, you're going to have to create your own supports. When you click the Make Hub button, the hub is actually comprised of 3 separate items in Matrix. 1 is the disc, 2 are the hub arms, and the third part is the calibration bar I referred to earlier in the video. You need to make sure that all 3 parts, so I'm going to hold down the Shift key and make sure I click on all 3 portions of the hub, and click the arrow underneath the custom hub box to input the hub into the hub window. We're going to go ahead and click Next. On this page, we can choose the cutter we're going to use and the distance between the tool paths. In this case, we're going to stick with the 10-degree cutter, and the distance between tool path is defaulted at 0.05 for my machine. Now you can change the default by going up to the STL options and changing the default distance between tool paths. I think when you first install the software, this is defaulted at 0.03. Okay, I like to use 0.05 for time reasons, for speed, and so I'm just going to click that and click Set. Once you set that, this distance between toolpath box defaults at whatever value you have set in the STL options. And what the distance between toolpaths actually is, we'll just take a peek at that real quickly. If we zoom in at this toolpath, the amount of space in between, it's sometimes referred to as step over, as the cutter comes across and back and across and back all along this toolpath, which defines the shape of the piece. So it is cutting this path out of the wax. The distance between the toolpath is 0.05. Obviously a 0.03 would make a tighter toolpath, increasing the quality of the surface finish also increasing the amount of time taken to mill the project. So experience will tell you what default setting you like to have there. I'm going to stick with the 0.5. We'll go ahead and click next. We could make our paths here, but I already know that we have some advanced options that we want to take a look at, so we're going to go ahead and click next. Starting from the top, we're just going to look through these options here, and then we're going to be adding some additional options. The very first thing that's going to happen is it's going to cut the hub. The second part is it's going to cut flat on the dual sides. And we've just got a subpart 1 and subpart 2, so that's side 1 and side 2. Then we've got a couple of hub part 1 and hub part 2. That is when it actually cuts out the calibration scale, which we'll take a look at later, and then the rotary option here. I'm going to go ahead and click Make Paths, and we'll take a look at our paths, and then we'll be able to tell where we need to alter them. I'm just going to pause this for this. So if we click back up at the top, you can see the very first thing that happens is, actually get rid of this, is it comes in and it cuts the hub out. So that's what these red lines are. If we wanted to toggle the STL option, you could see there's the little arrow cutting out the center hub. The next option, go back to STL. The next option is the dual, and this is when it's separated into two load parts, subpart 1 and subpart 2, and it's coming in and it's cutting flat down from this side and then flat down from the opposite side. Okay, milling out the form or the shape of the piece. And you can see that that 5-degree angle indeed is left on all of the parts. And during the rotary portion, it comes in and it just cleans off that 5-degree angle all the way around the part. Well, you can see from the tool path that it's only reaching the surface here in between the bridge. It's not touching the bridge down here. So if you remember the picture, go ahead and look at that again, you can see why it cleaned off that 5-degree angle left from the auto flip portion on just this center section, and the hand cleanup required here to mill that out. The other thing to take a look at that we're going to correct is, because the angle of the cutter always approaches from F4, so I'll just draw a little line here. The cutter's always going to approach along this axis. When it comes in to mill these prongs, you can see that it's only milling in from this angle. So it's not cleaning up anywhere underneath this prong. And we can do a much better job if we were to come in at a custom angle. So the first thing we're going to do is we're going to change the way the rotary path is going to mill the entire outside of the ring. We're going to tell it not to touch this center section. And what we're going to do for that is we're going to come in and we're going to click on the rotary on center option, and I'm going to double click that, and one of my options here is the cut angle. And the cut angle allows us to limit the amount on the 360-degree cut, so we can change the angle where it's going to cut. And the way that this works, it always starts milling from the start angle. I click this little line icon and it drags out from F4, and I'm going to drag my line up right to about there for my start angle, and my end angle I'm going to do the exact opposite side. So what's going to happen if I put my start angle in here and my end angle in here, it's going to start milling at the start angle and mill in the clockwise direction until it reaches the end angle. leaving the center section alone, which we'll clean up later on. Okay, so we'll go ahead and click Make Paths just so you can take a look at what that did. Okay, now if we want to take a look at just that one path, it requires you to click off of the current path and then click back on it. But then we can see that the center bridge is not being milled at all. That's exactly what we were looking for. So that looks good. Now we need to deal with these flat areas here that, or these areas here that aren't getting milled on the rotary. We're going to come in with a flat cut and mill them straight on, as opposed to milling them at an angle that doesn't reach them very well. So what we're going to want to do is we're going to want to click the Add button. When you click Add, it populates this menu with all of our options of paths that we can add to this strategy. And what we're looking for is the flat on hub. Okay, that's going to approach flat down on the hub fixture. So we'll go ahead and click that. And when I expand this, it allows me to open up my cut depth. When I open that up, it brings up the red preview item, and I can click the Go arrow and rotate my cutter into position, into the best possible position to get into the area that we're trying to mill. We want it to kind of be at the same angle as those prongs. So I'm going to back up the angle, and then I'm going to change the depth so that it goes just below the seat on this upper section. This is where I'm working. And if you remember, we're going to probably need to do a custom angle for this prong and this one. And once we get to this prong, it's reached pretty well from just the standard rotary option. So once I get my cutter in place where I like it, I'll go ahead and press the Enter button. And now that sets both the angle and the depth of the cutter. And as a reference point, what I typically do is I come over to the curve menu. You can go up and access any Rhino tool while you're in the Revo interface. And you can access them if you know where they live within these menus. So I'm going to use the curve and use a single line option. And I'm going to draw a line just as a reference point from the tip all the way to about the center of this cutter. Okay. Next up, we need to determine where this is cutting. So we've determined the angle and the depth, but we need to determine the border. So within the flat on hub option, there's a sub option for the border. We're going to click on that, and we're going to change from an automatic border to a manual curve border. And what this is going to allow us to do is manually draw a custom border. And we need to know what the mill is seeing, because all we're seeing are the standard 4 viewports in Matrix. If you click the Mill Viewport Show option, it opens up a 5th viewport that shows you exactly what the mill is seeing. So I'll just expand that. We can look straight down on this seat, and we know we can cut that pretty well. So I'm going to go ahead and access my border tool, my rectangle tool, and we're going to draw a rectangle that's just in that area. And I'm keeping in mind that the majority of this was already cut during the rotary section. All I'm doing is coming in and cleaning up some of this prong area and the seat that could not be reached well with the rotary pass, with the existing rotary pass. Now I've kind of lost my border. I can't see it underneath there. So what I can do is I can toggle to the should be the none option. That should not be there. I must have that object locked there. So I'm going to go back to STL option, and we're going to hit the hide viewport option here, and we should find that there is a border underneath that section. Okay, and that's what I'm looking for. So we can just go ahead and toss that rectangle into the border window. Now we need to do that again for the second stone down to make sure it's being cut properly. We're going to add another flat on hub, expand it, choose the cut depth, and rotate this around. Click the go button, rotate the handle, and get it rotated where it's lined up with this second section here of stones. We'll move that up to where it's just underneath the azure. That looks pretty good. Again, I'm going to put a reference line in. So curve, single line, and you'll see why I'm using this reference line in just a second. We're going to go from the tip all the way to the center here. Now we need to put in the border, so click on the border. We're going to do a manual border and a show. And now we're working on the second seat down. Curve, rectangle. I'm going to draw a little border that just cuts out that seat. Hide the milling viewport. Find that border curve and place it in the border window. Now we need to do the exact same thing over on the other side of the model. So the best way to do that currently is to grab these two border boxes and the two reference lines, and we're going to mirror them, transform, mirror, or you can type mirror into the command line box. Start of the mirror plane is going to be F4, shift and click. And now we're going to add two more flat on hub. And for the subpart 3, you can expand that. Either use your expansion button here, or you can just double click to expand and contract. Click on the cutting depth. We're going to rotate this around. And now I'm using my reference lines, my guidelines, for the angle of the cutter. You can see the tip should be right to here. We will verify this should be the second stone down. It should be right underneath the azure. That looks really good. So we'll go ahead and hit enter, and we're going to grab this second border down that we mirrored over, open up the manual border, and place the border in the border window. One more time. We've already added the pass, so expand it, depth, go, make sure, just kind of eyeballing it, making sure that it's centered up there, and then change the depth to match the tip of that green line. let's take a peek up at the top stone, and that should be just underneath the azure there. Press enter, open up the border window, open up the manual curve border, and grab that top border curve. That looks good. All right, so now let's go ahead and make paths, and we can take a look at those. So let's go ahead and take a look at the paths we just made. Again, click off of the path you want to look at and then back on. So we've looked at, let's see here, the rotary path, and you can see that it's just not getting in there to clean this top one or the next one down, whereas the ones after that look pretty good. So let's look at the flat on hub passes we placed in there. There's our first one, and you can see it's really doing a way better job at cleaning up those prongs and the seat. So there's our rotary path, goes all the way around the ring. And here's our new subpart 1, the flat path that's actually added in there to help clean that up. Goes all the way through the azure. The second one down, again, same thing, and then we should have basically the mirror of that on the other side. So that would be subpart 3. And subpart 4. And obviously subpart 4, something happened there. Looks like the border is not proper. So let's go ahead and open up the border. We're going to pick this border curve and place it back into the border window. This is why it's always super important to go in and look at all of the tool paths that you've created. Make sure that everything looks proper. And that looks a lot better. What had happened is this border curve got placed in the border window as opposed to this border curve. Okay, so that looks really good. Next up, we need to figure out how we're going to deal with this section here to fully clean up the area that we did not mill with the rotary. So I'm going to add in another flat on hub. Let's go ahead and do our cut depth. Click the go button, and let's change the angle to where it just passes. Actually, set it to where it just can come straight down into this little section here. And let's take a look at what the mill sees at that angle. So press enter and click border, manual border, and show. This is the top section. It's not, we can't see quite in where we need to see. So let's go back to the depth, and we're going to change the angle ever so slightly. Change the depth as well. That's too deep. Let's look at the mill view now. Much better. You can see right down into the crevice, and this is the bridge, and this is this piece here. So we should be able to draw a little custom border, curve, rectangle that comes right in here and mills the 5-degree angle off of that section. Click the border curve, place it in the border window. Hide the milling view. I'm going to go ahead and go back and tell it to give me my depth back so that I can draw a reference curve from the tip out to the center. And then we will mirror this over by typing mirror in the command line, F4 and shift. Add another subpart, flat on hub. Place the cut depth, click go to get your angle. And then set the depth using that green curve as a reference. And we will mirror this curve over to the other side as well. Now if we go to our border, toggle on the manual curve and show, we should see right down in that crevice. Click that border and place it in the border window. Let's hide our mill view. Incidentally, if you get to a point in the interface where you don't have access to the show and hide buttons and you have the milling view open, you can always right click on the milling view and drop down to the close viewport option. Go ahead and click make paths and we'll take a look at this again. Okay, so let's go ahead and take a look at this. We'll start here at the sub option 1, 2, looks good, 3, 4, and the 5th. That is coming down from about center and milling that section. We might not have met in the center completely, so if we didn't, we're gonna need to add in one more small pass. Six looks good, so we'll add one more flat milling on hub, expand that, click the cut depth, and at its default position is actually basically where we want it to be. I'm going to move it up just ever so slightly. We're going to draw our own custom border in there, and it's really not necessary to show the mill view because looking down view is the mill view from that approach angle. So we'll go ahead and change and draw a rectangle. There it is. Place that in the border window. Okay. It's almost the same color. You can barely see that tool path, but it's just going right back and forth. See it there, back and forth, back and forth. Cleaning up that center section there. And we are good to go. That should mill everything in its entirety for this project. I'm going to go ahead and click the Save Paths button. And we will save this as flat on rotary demo. Incidentally, if you're in the detailed options section, you do have to be careful. We've done a lot of work in here. If I need to go back and alter something that I've done on one of the first few pages of the toolpath builder, I will lose all of my work. So it's real important that once you're on this page, that you'll be able to remain on this page until the entire project is complete. Otherwise, you're going to do some work here, use the back button, and you're going to lose all of the work that you've done. So make sure that you don't go back and forth once you've completed your detailed option section. And that'll do it for the flat milling on rotary.